Hello everyone, welcome to Eduxcite classes. My name is Monit and in today's session we will start with the higher level and standard level both for paper 1B. This is the specimen paper for 2025, the new syllabus. Okay, so the combination of paper 1 and 1B is of 2 hours. I have already solved for both HL as well as SL for paper 1A, that is the MCQ. And if you have not watched that video, the link is given in the description. Please watch, it's very quite useful. Okay, so a clean copy of physics data booklet will be given to you, and a maximum paper for 1B, that is what we are solving today, is 20 marks, and it is common for both HL as well as for SL students. Okay, and a calculator is required for this paper, so don't worry about the calculations. So let us start with the very first question. A group of students investigate the motion of a conducting ball. This is the conducting ball which is suspended from a long string. So this is suspended from a long string, and the ball is between the two metal plates that have an electrical potential difference of V. The ball is touched to one plate so that it becomes electrically charged. So let us say this is positively charged. You can see this is the positive terminal. So this will be positively charged rod and this will be a negatively charged rod. So it become electric. So initially it become positively charged and it is repelled from the plate. Now this will be repelled from this for a given potential difference. The ball bounces between the plate with a constant period. So the ball will bounce with a constant time period t. Now the question A, the student vary V, that is the potential difference, and measure the time t for the ball to move once for one plate to the other. Now this is the time period t from one plate to the other. This is time t. Okay, and the data are as shown. Now V is provided by two, this is very important, two identical power supplies which are again connected in series. So this will be like this, two power supply. Now the potential difference for each of the power supply has an uncertainty of 0.01 kilovolt. State the uncertainty in the potential difference V. So we know that there are two power supplies and each have an uncertainty of 0.01 kilovolt. So the answer for the uncertainty in potential difference for the total V will be what? It will be 0.01 plus 0.01, which will be nothing but 0.02 kilovolt. So this will be the uncertainty in the potential difference V. Okay, quite simple. Uncertainty or the always gets added. Okay, so do not get confused. Now t is measured with an electronic stopwatch that has the nearest, which is 0.1 second. Describe how an uncertainty in t of less than 0.1 second can be achieved using the same stopwatch. Now whenever we are dealing with experiment or the investigation which require the stopwatches, so in order to minimize the uncertainty will always be there because of the reaction time, right? But in order to decrease the the uncertainty in t, what we generally do is we can have, so we can be achieved using this stopwatch by taking 3 trials each of 10 oscillation and measuring the average time period t. So what we can do is we can measure like from 1 till this. So we will measure these 10 and then we will divide by the total number of oscillation, that will give 1 t. Similarly we will try for 3 t and then we will take the average of these 3 t. So this 3 divided by 3, sum of these 3, whatever the values you will get, divided by 3. Okay, if you have any doubt just comment below. I will try my level best to give you your explanation as early as possible. Now the graph shows the time t in second with the voltage in kilovolt. The uncertainty V is not plotted. So the uncertainty in the V is not plotted, only the uncertainty in the t is being given in the graph. Outline why it is unlikely that the relationship between t and V is linear. So it is not linear. Unlikely means it is not linear, because you can see that if I want to join the points, I cannot join with a straight line. All the points are not passing through the error bars. The line, straight line is not passing through the any of all the error bars of the points that are plotted. Okay, so what we can say is it is unlikely because it is not possible to draw a straight line, because linear means it should have a constant slope. It is not possible to draw a straight line which passes through all error bars. Okay, you cannot draw. You can try, like you cannot draw a straight line which passes through all the error bars. Now calculate the largest fractional uncertainty in T for these data. So fractional uncertainty is what? Delta T over T, and the largest will be when, look, uncertainty in T is same, which is 0. You can see here 0.1 second, right? So delta T is same for all 0.1. Now for largest, the T has to be minimum, right? So the T has to be minimum. You can see these are the data for T is minimum. Rest all are having the T value of T as higher. So because we have to find out the largest, so the denominator have to be minimum. So this data, if you see, it will be 0.5. So 0.1 divided by 0.5, 1 by 5, which is 0.2. So 0.2 is the answer for the fractional uncertainty in T. Okay. Now the student suggests that the following theoretical relationship between T and V, where A is a constant, and to verify the relationship, the variation of T versus 1 by V is plotted like this. Okay. Determine A by drawing the line of best fit. So we have to find out the constant value of the constant A. Okay, so what we can do is first draw the line of best fit. So if I want to draw a line of best fit, so the line of best fit should be drawn such that it is equidistant from the points are at equidistance from the line of best fit. It should be drawn like few points are on the other side and few points are on the another side. Somewhat like this you can draw. I think this will be the line of best fit. For such answer you will get a range in the marking scheme also. The range will be given somewhat closer to that. Okay, so this is the line of best fit and I have to determine the value of A. Now it is the graph between T and 1 by V. So the relation is what? So can I say A will be T into V? Okay, so and if I calculate the gradient of this, so the gradient will give me what? The slope, or the gradient will give me T by 1 by V, right? So T by 1 by V is nothing but T into V, and T into V is nothing but A. So A is nothing but the slope. So if I find out the slope, that slope will be nothing but the value of A. Okay, so A is the slope of, or you can say the gradient of T versus 1 by V graph. So you can, I hope everybody knows how to find out the gradient. Take any two arbitrary points, x1, x2, y1, y2. So for simplicity, what I can do is I can mark 2 points which cover at least 50% or 70% of the graph. So one point is my this one, and another point I can take is, let me take this point, this one. Okay, so this is 0.1 2 3 4, this is 0.34, this is 0.1, this is 0.4 here, and this is 0.14. so A will be what? A will be y2 minus y1, 1.4 minus 0.4 divided by 0.34 minus 0.10. So this will be 1.0 divided by 0.24, right? So this will be 1 by 0.24 which is roughly, you can say it is 4. Okay, so 4.1 something it will come, right? So 4.1, so it will be something around 4, you can say. So that will be the value of A. Now state the unit of A. Now unit of A is nothing but T into V, right? T into V. So T into V is that will be second into kilovolt. So kilovolt second will be the unit of A. Simple, just T into T is second, V is measured in kilovolt. So kilovolt second is the unit for A. The theoretical relationship assume that the ball is only affected by the electric force. So we assume here that the ball is only affected by the electric force. Suggest why in order to test the relationship, the length of the string should be much greater than the distance between the plate. Now, why in order to test the relationship the length should be greater? Because if you see, if I take this length, okay, and it is swinging between the two plates like this, okay, like this. So the length has to be very larger as compared to the distance between the plate, that is this. The reason being, it has to make a very smaller angle so that the only force which is acting is the electric force, otherwise the tension have its own component, because if you see the ball will has its own weight. So one will be the mg, one will be the tension. Okay, now this will have a certain angle, so this will be theta, so this will be t cos theta and this will be t sin theta. Now if theta is small, then what will happen is the component of t will counterbalance with the mg. But if theta is large, then this component will be larger and it will play a significant role. So only electric force will not be there, there will be a component of the tension force also. Okay, I hope I have tried. If you didn't get what does this theta is small and how this component works, just comment below. Okay, I will try, or you can watch again. I mean to say, if the length is too much, then this theta will be small because it will have a very less displacement from the mean position. So if theta is less, then this t cos theta will get balanced with the mg. This will be very small, or you can say it will be negligible, because the vertical component will be negligible. Therefore only the electric force, that is the electrostatic force of repulsion between the plates, will act. Okay, so you can say the length of this string should be greater so that the angle, the displaced angle will, or you can say the displaced angle will be smaller, so that the tension will be balanced by the weight of the ball and only electric force will act in horizontal direction, because the vertical forces are balanced. Otherwise there will be a horizontal component of the tension, because sin theta will be larger, so this theta will be greater, then we cannot neglify the effect of the tension. Okay, now the second question for the 1B paper. A group of students investigate the bending of a plastic ruler that is completely clamped horizontal at one end. Okay, a weight W is attached to the other end, causes the ruler to bend. The weight is contained in a scale pan. Okay, so the weight is contained in a scale pan here. The student fixed the length L of the ruler and vary the weight which was carried. The group measures the deflection from one end of the ruler to which the weight is attached, and these are the data that they have gathered. Now this group is divided into subgroups of A and B to analyze the data. Now the group A quotes that the mean value of this D is 2.93, whereas the other group quoted the value of mean value of D as 2.8. Now discuss the values that the group have quoted. Now in such type of question where we have to discuss on or we have to comment on the data or the analysis of the data gathered by the students, so make sure first of all what you can do is for group A what we can comment is just take the sum of all these deflection and divide by number of readings, that is 6. So what group, if you do this you will get something around 2.93. so what group A has done is group A has get the mean value of D by taking average of all the data. Okay, so they get 2.93, whereas if you look at the data closely, 2.7, 2.9 and this 3.6. Now this 3.6 is getting very absurd value as compared to the other trials. So this data might have some error in it. There might be certain random or systematic error might be there, so that we are getting deviation from the mean or something expected value of the readings as compared to the other trials. So the group B, what has they have done, they has not taken the reading number 3 into consideration, and the group B has overlooked reading 3 as it is deviating from the trend or pattern from the trend due to some errors, and hence they take the average of remaining 5. So that is remaining 5 readings. So that is what we can discuss about the groups, about their mean value of D. Okay. Now the variation of D with W is shown to us. Now this is D, this is W, and this is the variation. Outline one experimental reason why the graph does not go through the origin. Now you can see when there is no weight, still there is certain deflection in the plastic ruler. So we can say this is because of the plastic ruler will also have its own weight, and due to its own weight also it might get deflect certain from the horizontal. Okay, so we can say this might be due to its own weight, as it is of 1 mark, that might be enough. Okay, now the theory predicts that the deflection is proportional to W raised to power x L raised to power y divided by E into I, where E and I are constant, and the fundamental values units of I is meter raised to power 4 and those of E is given to us. Now we have to calculate the value of x and y. Now we know that deflection, so in such a case we have to use the dimensional analysis, which suggests that the dimension on the left hand side of the equation must be equal to the right hand side. Right now it is a proportional sign, so we make it as equate with the powers. Okay, because there might be certain constant value which will not affect our results. So on the left hand side it is meter raised to power 1 because it is deflection, and deflection will be a measurement of length. So the SI unit is meter raised to power 1 because all are in SI units. Whereas W I don't know, so I can say W is the weight, and weight is a unit of, this is in newtons, right? So what we can say, Newton is, if you know, Newton is mass into acceleration, which is kg meter per second square. Okay, so what I can do is W I can write kg meter, kg1 meter 1 s minus 2 raised to power x. L is what? L is the length. Okay, L is, here you can see in the yeah, L is the length of the ruler, which is again in meter. So L raised to power, L is in meter, so just write meter raised to power y. Now this gets divided with E. E is again given as kg, m minus 1, s minus 2, and E is this, and I is m raised to power 4. Now if you see on the left hand side, the kg is not there, second is not there, right? So probably this will be only possible if this kg and this kg gets cancelled, and s minus 2 and s minus 2 gets cancelled. It means x has to be 1. So comparing the powers, we got x equals to 1, because kg will get with kg cancelled, s minus 2 s minus 2, because there is no kg and second on the other part of the equation, right? So this and this gets cancelled, this and this gets cancelled only and only when x is equals to 1. Otherwise there will be certain value, and you can see on the left hand side there is no kg is 0 as well as s is 0. So that will only possible when x is equals to 1. So we got the value of x as 1. Now for y, what you can do is, this is equals to 1 on the left hand side, so x we already got, so m raised to power 1, that we are comparing the powers only, x plus y minus 1 plus 1. This minus will go to the numerator, you will get plus 1, and this 4 will go to the numerator, you will get minus 4. Okay, so we get this expression, and now we can put x as equals to 1. So this will be 1 1 plus y plus 1 minus 4. So you can see this will be minus 2 plus y equals to 1, and y will be equals to then 3. Minus 2 goes to other side, 3. So x is equals to 1 and y is equals to 3 for this theory. Okay, I hope I have given you enough explanation how to get the value of x and y. Even though if you have doubt, just comment below. Okay, now the D part, the cross sectional area of the ruler is a into b, where a is given and b is given. We have to suggest an appropriate measuring instrument for determining b. Now you can see b is 0.05 mm and it is very small, and we know that to measure lengths which are in millimeters, we generally use the micrometer screw gauge. So those who have gone to this physics lab, they might have used this instrument, which is just, there are two jaws and a circular disc is there to rotate, and you keep the object in between the two jaws. One is movable, one is fixed, and when you tighten the nut, you will get a value on the circular and the fixed scale reading. So micrometer screw gauge, even you can use the vernier as well to find out the smaller measurement like 3 mm and precision up to 0.05 mm. Now we have to find out the percentage uncertainty. Now we know that percentage uncertainty is delta A over A into 100. Now this delta A into divided by A into 100 is A into B. So that will be delta small a over A plus delta B over small b into 100, because we have to find out percentage. So this is what we have to find out, which is delta. Now delta A is nothing but 1 mm. So 1 by 28 plus, always uncertainty get added. So delta B is 0.05 divided by 3 times 100. So when you solve this, okay, you will get value. You can solve this in your calculator. I have already solved. So this will come something around 0.05238 times 100. So up to 3 decimal, you can say, or up to into 100, it will be 5.23, or simply you can say 5%. So the percentage uncertainty of A is 5%. Okay, so this is all from my side. I hope you like this video. Make sure that you share with your friends, and if you have any doubt, just comment below. And if you want one-to-one session with me for your physics IBDP, the links and the details are given below. Just check those details and please share. See you in the next video. Please take care, keep learning. Bye bye.